to all. Myself Mrs.D.Sudhamaheswari, Assistant Professor of Computer Science, the Standard 5 Rajaratnam College for Women, Sivagasi. In this session, we are going to see about a dynamic programming approach 01 knapsack problem. In this session, we are going to see about an introduction to dynamic programming and what is knapsack problem and its variants, and 01 knapsack problem and a sample solution and its advantages and applications. Dynamic programming is a method for solving certain kind of problems, and dynamic programming can be applied when a solution of a problem includes the solution of a subproblem. That is, when we find out a solution for a subproblem, a small problem, that result can be applied to the major problem. Here we have to find recursive formula for a solution. Then starting from a trivial case, recursively apply to solve subproblems and save their solution in memory. It is essential. Finally, we can get the solution for the whole problem. What is knapsack problem? It is a combinational optimational problem. So, whenever we want to solve a problem, the solution should be optimized. It is a best approach. For example, let us take a bag with a maximum weight of capacity W, that is 20 kg, and with and a set of items each having a weight, that is let us consider we are going to move to a department store. The items have groceries such as in the various weights. We have to put into a bag which has the capacity of 20 kg only. So our problem is to which items are to be inserted into the bag, but its value to be high. It should be a more value. That is the knapsack problem. So here the original problem is how to pack the knapsack to achieve maximum total value of packed items. We have items with values, so we have to include the items with maximum values into the knapsack or bag. So the knapsack problems have different variants. There are 4 types of knapsack problems. They are fractional knapsack problem, 01 knapsack problem, bounded knapsack problem, unbounded knapsack problem. Here we concentrate only on 01 knapsack problem only. 01 knapsack problem, in this the items given are indivisible and we cannot take the fraction of any item, that is, we cannot take an item as half or quarter part of this. We have to either take an item completely or ignore it completely. We can use dynamic programming approach to solve this type of problem. Let us consider a bag whose capacity is W and the number of items to be included whose weight and value is equal to n. Let us have an initial table T whose columns are weights and whose rows are number of items with weight and profit value. Here we can fill the cells in the table. We have to fill up the cells with the value of an item whose weight is less than or equal to the capacity of the knapsack. Here we have put as in the 0th and 0th column and 0th row as 0, because 0 weight capacity bag could not contain any item. So we provide the initial table with zeros in 0th column and 0th row. The formula to fill up the cells is T of I j is equal to maximum value, maximum of T of I minus 1 comma j comma value of the item's value plus T of, that is the cell I minus 1 comma j minus weight, that is the item weight. Here the T of ij is the maximum value of the selected item. Here the procedure, if j is less than the weight of items weight, then we fill up the cell with previous weight, then previous weight value, else we have to find out the maximum value. So here the maximum value, 2 variations. So we can implement this by using an here we consider an example, a bag with maximum weight 8, let us take it as 8 kg. The number of items given are 4. The weight of the items for each item is 3, 4, 5 and 6, and whose value is 2, 3, 4 and 1. Our initial table, here our initial table. In this initial table we put the 0th column and 0th row as 0, and here these are all the items numbers with whose weight and profit value. For example, the first item is weight is 3 and value is 2. We are going to fill up these remaining cells with the profit values, maximum profit values. We can solve this problem by using dynamic approach. We can find the steps to solve to fill up these cells. First, initially take the weight of sack is as 1, and we have only one item 1. Then we have the sack with capacity 1, and the weight of the item is 3, so we cannot put this here, we cannot fill up this, so we put 0 in this. Then likewise increment W by 1, then W is equal to 2, we cannot insert the item. Then W is equal to 3, you can insert the item whose weight is 3, so we can put the value as 2 in this cell. Then increment 4, we have only one item, that is no change in the further cells. Then increment the item by 1, here W is equal to 1, that is weight is equal to 1 and item is equal to 2. So we have 2 items here, 1 and 2, whose weights are 3 and 4, values are 2 and 3. We can choose whether to insert into the bag. So first of all, when W is equal to 1, we cannot insert any item. When W is equal to 2, we cannot insert any item, and W is equal to 3, we can insert the first item, that is already we have find out the value 2 as 2. Then for 4, when weight is equal to 4, we have to find the maximum value to apply in the cell. So here so that is the cell name is 2, 4, that is the second row and 4th column. Here we have to put the maximum value, that is the maximum profit. So here the 2, maximum of 2 is the previous value in the column. Then 3, our new column, new value of the item, then plus T of 1. This is arrived by that is the 4 minus 3, that is the 4 minus 4, that is 0. First column 0th row, first row 0th column, that is this one. So this value add this value we can include. So 3 plus 0 is equal to 5. So maximum of 2, 3 is equal to 3. So we have to put 3 in this column, in this cell. Then increasing the weight by 1, weight is equal to 5. Again we have the same problem, whether to what to include in the cell. So here we have to fill the 2, 5 column, 2, 5. So this place maximum of 2, that is the previous value 2, our new value 3, plus this one, that is 5 minus 4 is equal to 1, that is the first row and the first column, the value is 0, that is 0. So there is no change. Maximum of 2 comma 3 is 3, so there is no change. Again we increase the weight by 1, weight is equal to 6, then it is equal to 6, then 6. So we have to fill up the 2 comma 3 this cell, maximum of 2 comma the previous one 2 and 3, our new value 3 plus 1 2, that is 6 minus 4 is equal to 2. So second column, first row second column, that is also 0, so no change. Then coming to the next value, w is equal to 7, here we have to concentrate on like this, maximum of 2 comma 1 minus 1 cell 1 comma 3, that is 7 minus 4 is equal to 3, that is the first row and the second third column, that is the value whose value is 2. Here 2 comma 3 plus 2 is equal to the maximum of 2 comma 5. The maximum of 2 comma 5 is the 5, so we put this 5 in here. So likewise, by incrementing weight as weight by 1, so now weight is equal to 8. We have to fill up this column, likewise maximum the previous value 2 and 3 plus, that is the new value, plus t comma 1 this value. So like this, maximum of 2 comma 5 is equal to 5. Then again increment I by 1. Here w is equal to weight is equal to 1 and item is equal to 3. That is, we have 3 items in the bag. We can choose any item from the 3 that fill up the capacity of the sack. So like here, like this 0 0, there is no item to fill up the bag with 2 kg capacity, and then 3 kg we can use the previous one value as first item only, then 3, so previous value. So likewise we can fill up this with the formula using. Then our final value, final table is here. We conclude we'll fill all the cells using the above formula. The maximum value is 6. This is 6, which this value is derived from the previous one. So we cannot choose this item to put in the bag. So move on to the item 3. So we can choose item 3 to put in the bag whose weight is 5. So whose profit is 4. Then so now choose the third item. Move on to the second item here. The third item weight is 5, so you have to minimize, so back 5 column. So 1 2 3 4 5 2, which is also derived from the previous one. So we cannot choose this item, but then move out the first item, which is the fresh one, which is not derived from any other. So you can choose item 1 to put into the bag. So the item 3 and 1, the weight 5 plus, that is 5 plus 3, so it is equal to profit value 4 plus 2. Here for the first derivation, we choose the item 3 whose weight is 5 and profit 4. The second derivation 3 comma 1, that is the second first item and third item whose weight is 5 plus 3, then profit is 4 plus 2. So here the optimum solution is 3, item 3 and 1. We can put the item 3 and 1 in the knapsack, and whose value is the most maximum value is 6. The knapsack problem has some advantages, that is it is easy to understand and apply. The knapsack problem often provides optimal solution to a problem, and it is very efficient to all. Then there are many applications in knapsack problem. The knapsack problem can be applied in resource allocation, job scheduling, project planning. When a job is scheduled with a constrained capacity of timing, we can use knapsack problem. Finally, the knapsack problem can be solved using dynamic approach, in which we have to create a table to store the maximum value that can be obtained at each combination of items and weight. Each solution should be stored in the memory. Then by iteratively filling this table, the optimal combination of items and their total value can be determined. It yields the very efficient solution, a very efficient or optimized solution to a problem. I hope this session will be very useful to you all. Thank you everyone.